Hello. So this time we're going to go over an application to systems of linear equations to the problem of interpolation. So this time we have this. Find a quadratic function, meaning an expression of the form ax squared plus bx plus c, where a is different from 0, whose graph passes through the points on the coordinate plane 0, 1, 1, 4, and 2, 9. Now, how do we set up this problem so that it represents a question on systems of linear equations? Well, first thing is to note that what we want is this. We have the following information. As we're given these points here, what we really have is that f evaluated at 0 should return 1. F evaluated at 1 should be 4. And f evaluated at 2 should be 9. But of course, this equation that we have here is actually the following. This indicates that we have a times 0 squared plus b times 0 plus c is equal to 1. This equation that we have here might be encoded in this fashion as a times 1 squared plus b times 1 plus c is equal to 4. And finally, this equation that we have here actually is the following. It's a times 2 squared plus b times 2 plus c is equal to 9. Of course, we can rewrite it in the following way as simply 0 times a plus 0 times b plus 1 times c equal to 1. 1 times a plus 1 times b plus 1 times c equal to 4. And now we have 4 times a plus 2 times b plus 1 times c is equal to 9. And what happens here? Well, here we have 3 equations and 3 unknowns. The unknowns being a, b, and c, the coefficients that are associated with this polynomial expression. Okay, but look, this can be turned into a matrix, right? What matrix? Well, from here, the following. We simply have 0, 0, 1 with 1. We have 1, 1, 1, 4, and we have 4, 2, 1, and 9. Right? This being the column of A, this one of that of C, this one of that of B, and that one of C, and the constants, of course, right? To the right of the equations. Now, time to do some operations. As you can see here, we have a pivot that we can use to eliminate a few things. So the first operation that I'm going to perform is the following. To row number 3, I'll subtract 4 times row number 2, and I will obtain the following matrix: 0, 0, 1, 1, 1, 1, then followed by 0, negative 2, negative 3, and here in this column 1, 4, and negative 7. Next, I'm going to exchange 2 rows, meaning I'm going to exchange row 1 with row 2, and now I have the following expression, so following matrix: 1, 1, 1, 4, then 0, 0, 1, 1, then 0, negative 2, negative 3, negative 7. One more. I'm going to exchange row 2 with row 3 and obtain the following matrix. I have 1, 1, 1, 4. I have 0, negative 2, and negative 3, negative 7, 0, 0, 1, 1. After this series of operations, what we have is that this column is in the form that we want, so we may proceed to choose a pivot for the next one. But to do it, well, look, this one is non-zero, and it's at the right location, so why don't we just simply multiply it by negative 1/2 on the second row. So that would be negative 1/2 on row number 2, and we will obtain the following: 1, 1, 1, 4, 0, 1, 3/2, 7/2, followed by 0, 0, 1, and 1 on this entry. Okay, next operation. I still need to eliminate this entry, and I'll do it by a simple subtraction. So I have the row number 1, I subtract row number 2, and we'll get the following matrix. We have 1, 0, negative 1/2, followed by 1/2, then we have a 0, 1, 3/2, 7/2, and 0, 0, 1, 1. Okay, so now both this one and this one are in the form that we want, and we move to this, and now we can use this as a pivot to eliminate. And to do that, I'm going to signify two operations, well, in a single one, but each of them are applied on different rows. To row number 1, I'm going to add 1/2 of row number 3, and to row number 2, I'm going to subtract 3/2 of row number 3, and I will obtain the following matrix. I have 1, 0, 0, then followed by 1, then 0, 1, 0, 2, then 0, 0, 1, 1. Okay, look, I recovered things, this being the equation number 1, this one equation number 2, equation number 3. But what does it mean? Well, this means that A, B, C, constants, that A is 1, B is 2, and C is 1. So we have that f of x is simply x squared plus 2x plus 1. And you can verify that this quadratic function, well, has these 3 points as members of its graph. I hope that you like it. Take care.